Voilà, soyez le bienvenu. Welcome. We look at structures in the field of engineering, civil engineering to be specific. We deal with structures. What's the definition of a structure? A structure is simply any system of connected parts designed to bear loads, withstand environmental forces, and transfer them safely to the ground. So, this interconnected system of different parts that are designed to bear loads is what we call structures. In the field of construction, there are basically two types of structures. When you talk about interconnected systems, we're talking about these different parts. We're talking about beams, columns, we're talking about tie beams or strap beam or reinforced beam. We're talking about blocks. We're talking about all these structure members connected together. So in the field of construction, civil engineering, we divide or we categorize structures into two parts. They are what are known as frame structures and load-bearing structures. Frame structures. Frame structures, these are simply structures that consist of beams and columns. These are connected together, okay, in which loads are transferred from each member directly to the ground, from the foundation to the ground. So the types of structures that consist of beams and columns are what we know or what we call frame structures. Frame structures. So in the strength of materials, I believe you were introduced to the calculations of reaction forces at this particular point in between supports. For example, this beam is supported by this column here. Okay, this column here. So the reaction forces, calculating load bearing capacity in relation to the type of foundation. So these structures that consist of beams and column is what we call frame structures. Okay, the second type of structures we have in construction is load bearing structures. These are structures that carry their own weight transmitted through walls, and the walls transmit the load directly to the ground. They do not consist of beams and columns, but they consist of simply walls in which loads are transmitted from columns. Loads are transferred from this slab directly to the walls, and from the walls direct to the slab to walls, and direct to the ground. So these type of structures that consist of these structure members are known as load-bearing structures. In enhancing this presentation, we are going to add a few points about the number of floors when we are considering frame structures. Let's begin with frame structures. Frame structures, remember, they consist of beams and columns. There are minimum standards, thumb rule standards that a good engineer must understand and must know in the designing of different types of frame structures. For frame structures, they might have ground floor. That simply means it has no upper floor on top of it. That is ground floor. The G here represents ground floor. So if it has got a floor on top, we say G plus 1, it becomes an upstairs building. So G plus 1 meaning one floor on top of the ground floor. G plus 2 meaning two floors after the ground floor means 1, 2, 3. But we say we do not count the ground floor. So when we say G plus 3 meaning three floors after the ground floor. So usually there are minimum standards for beams and for columns when you're considering G plus buildings or frame structures. Okay, for example, when you are designing beams and you're designing for a G plus 0 building, that is a ground floor building, the minimum standard should be 230 millimeters times 200. We're talking about depth and width. Depth and width. These are the sizes. For G plus 1, it should be 230 times 300 millimeters. These are the minimum standards. For G plus 1, G plus 2, for G plus 6, we have 380 millimeters times 450 millimeters in depth. So a good engineer must have these at his fingertips when we are designing it. For example, a G plus 10 building, it means the size of your beam will be, the width, it will be 530 millimeters times 530 millimeters. These are the minimums, okay? Minimum that you must know when you're considering frame structures or other structures, yes. Then we talk about frame structures to be specific. For columns, sizes for different floors, okay? For a G plus 0 building, ground floor building, the minimum should be 230 times 230. For a G plus 1 building, 230 plus 200 times 300 millimeters. Okay, for a G plus 2, these are the minimum standards that you must have in order for your structure to stand as minimum. Okay, that simply means if, for example, we are constructing a G plus 2 building, meaning from ground floor, 1, 2 on top, 2 floors, it simply means the sizes of my columns, the minimum should be 300 by 300 from the ground. From the ground. Okay, very important, because if you design as an engineer for a G plus 2 building, then you construct columns with the sizes of 230 by 230, then likely your columns are going to fail. Okay, you say that they're going to fail, they're going to buckle, they're going to have all those structure failures on site. So this is how you consider the minimum standards for ground floors, specifically for frame structures. Let's move on to load-bearing structures. See you.